All right, today we are moving on to comparing and ordering fractions. And again, remembering that our big idea is knowing what numbers mean helps us to compare things and solve problems, should be added there. And solve problems, there we go. So today we are working on comparing and ordering fractions. There's a number of different strategies that can be used for comparing and ordering fractions. We'll talk about a number of them today. Right, let's start and take a quick look at our first question here. I have 3/4 of a dollar, so 3/4 as a fraction. And I have 3/5 of a dollar. Who has more? How do you know? Turn and talk to your elbow partners. Press pause and turn and talk to your elbow partners. Any thoughts on which one of those fractions is larger and why you think so? All right, so which fraction did you say was larger? If you said 3/4, you would be correct. The reason being here that we have one item that again we get 3 parts of, and it's divided only into fourths. And remember, when we divide for fractions, we want our pieces to be equal sizes. So we have 3 items here. Now if I was comparing that same amount, which is a dollar, but now I'm dividing it into fifths, I'm going to try my best here to get them into equal fifths. As you can see, my parts are a little bit smaller, and 3 then, shaded in, would be a smaller amount. There's a smaller section of this one shaded in as there is of this one. As you can see, this one, 3/4, would make it up to this point. So that's one way of comparing and ordering fractions. That's called using strips or paper strips, whatever strategy you want to, whatever you want to call it, but strips is kind of the big idea. The main point when you are using strips is that those pieces have to be the same size. The other thing you could think about is perhaps thinking about your fractions in sets. So if I have 4 cookies and she has 5 cookies, and I get to keep 3 of mine, and she gets to keep 3 of hers, well, she's really giving away more. I'm giving away less, so my fraction is larger. That might help too, like thinking about it in sets. All right, so let's go along and we're going to do some practice together and look at some specific examples. All right, so we are going to look at 4 different strategies for comparing and ordering fractions. Our first one is strips, which we've talked about a little bit already. There's some criteria when you are creating your strips that have to make sure to happen. So here they're actually folding and measuring paper strips, and you can definitely use actual paper strips. Some students have found that they just prefer to draw their strips, and that's okay too. In order to use strips, you need to make sure that your strips are the same length, okay? Same size. As you can see, all of these strips are the same size, but this one has to be divided into 3/4. So that means it has to be 4 equal size pieces. This one has to be divided into 3/5 or into fifths. So that means 5 equal sized pieces. This one would have to be divided into eighths, 8 equal sized pieces. So you might want to use your ruler and decide how long your paper strips are going to be that way. But it's really a little tricky to make sure that you divide them as equally as possible, because remember, those pieces need to be equal in size. These fourths are all the same size. I could not have this drawn like this and say that these are equal fourths, because this one is a whole lot bigger, and then that strip does not work. The other thing that's important, of course, is remembering that all of those strips need to be the same length to begin with. So a couple of those things that you need to make sure you're remembering when you are working with strips of paper. But as you can see here, they've done this correctly. All of the strips are the same length. They have them in equal divided parts. And here 3/4, so we take our fourths and we color in 3 of them. And here we take our fifths and we color in 3 of them. And here we take 5/8 and we color in 5 of them, sorry. And now we see which is the smallest fraction? Well, that would be this one because it has the least shaded in. So 3/5 is our smallest fraction. 5/8 has the next most colored in part, so it's our middle fraction. And 3/4 has the most colored in, so it is our largest fraction. Strips work really quite well, especially when you are comparing 3 or more fractions. Works really well. It's a good strategy to use when it's more than just 2 fractions that you're looking at. Let's take a look at the next strategy, and these are called fraction circles. And again, it's the same idea as the fraction strips in that the circles are the same size, and then they're just divided accordingly. So for example, here we have 3/4, so we need to divide it into 4 equal pieces. Now this is the hard part about circles sometimes, is getting those pieces to be the exact same size. So you have to really watch when you're drawing your circles. Here we have another one that's going to be 5/8. Eighths, again, you need to make sure you're dividing your fraction circle so that all your pieces are as equal as possible. And then do the shading in and see which fraction circle has more colored in. That works quite well. The key there being if you are able to draw circles with equal pieces. Not so bad when your circles are even numbers, but often circles and trying to divide them when they're odd numbers can be really tricky. So that would be thirds. Fifths is really tough to do in a circle. Yeah, see, I can't even do it. All of those part pieces aren't the same size. So I would hesitate to use circles if it's an odd number because it makes it a lot trickier to divide. When it's an even number, it's not so hard. So for 6, for example, I'm going to take it, cut it in half, and then I know I have to have equal sized pieces. So there we go. That's not so bad. Okay, so that would be fraction circles. The last one, no, not the last one. The second last one is number lines. And with number lines, sometimes a benchmark is helpful. And a benchmark is, okay, so is this closer to, benchmark, can't see my K there very well. Is this closer to 0? Is this closer to half? Or is this closer to 1 is part of what we generally consider when we're comparing them on a number line. Okay, so again, you're going to draw one line. Some students like to do this kind of like fraction strips and have a number of lines on there, which is okay too. When you're drawing your number line, we want to put on there here 1/2, 3/4, 1/4, and 5/8. So I'm going to have to divide my line into my biggest sections here. So I've got 8. So I'm going to divide this line into 8 sections. So I've got a half. Then in each half I have 4. And those sections, again, just like the number strips, need to be equal in size. Okay. So I'm going to start with 1/4. And now I'm just going to ignore every second. I'm going to take this and I'm going to divide it into 4 equal pieces. And then this, of course, being the 0, so that would make this the 1/4 line. This would be 2/4. This would be 3/4. So I can easily put now my fourths on there. So 3/4 and 1/4 are on there. 1/2 is not too bad because I know it's just half of that. And 5/8 is my trickiest one. I'm now going to have to count all of my eighths. 1, 2, 3, 4, 5. So 5/8. So now I can look at this and compare to see which fractions are smaller and which fractions are larger. So I can see that 1/4 is my smallest fraction, 1/2 is my middle fraction, 5/8 is larger, and 3/4 is the biggest. Using benchmarks to help me, I could see, okay, 1/4 is definitely closest to 0. 1/2, well, is really close to half. Benchmarks gets tricky when it's 5/8 and 3/4 because it's hard to sometimes know which one is closer to the 1 benchmark. So at that point you might need to really draw out your line very carefully and look at those two carefully. So that would be number lines, and with the addition of using benchmarks a little bit to assist you. And the last strategy, which works really well when there's only two fractions, is equivalent fractions. So this builds on what we did last day, is to list the equivalent fractions or find the equivalent fractions for 2/3 and 3/5. All right, so here they're listing all the equivalent fractions, which works quite well. So 2/3, oops, sorry. Let me get rid of that little box. 2/3 is equivalent to 4/6. I've multiplied by 2. Now I go back to my original fraction, 2/3, and I multiply both by 3. So I'm not continuing to work with the 4/6. I'm going back to my original fraction. And now I'm going to multiply by 3 for the top and the bottom. 2 times 3 is 6. 3 times 3 is 9. And then I can look at 8/12, or 4, multiplying by 4. 2 times 4 is 8. 3 times 4 is 12. 2 times 5 is 10. 3 times 5 is 15. 2 times 6 is 12. 3 times 6 is 18, and so on. And then I'm going to do the same thing with 3/5. 3 times 2 is 6. 5 times 2 is 10. 3 times 3 is 9. 5 times 3 is 15. 3 times 4 is 12, 5 times 4 is 20, 3 times 5 is 15, 5 times 5 is 25. So now I have a number of fractions to compare. And I'm probably going to look at these two because I've got 6 of each again, 6 and 6, but now I'm only dividing it into 9 pieces. Now I'm dividing it into 10 pieces, so I know that this number is larger because I've got 6 of them, but the whole item is divided into fewer pieces. There's one more way that I'm going to add, actually, and that is cross multiplication. And now with cross multiplication, it only works well when there are just two fractions. It doesn't work well when there are multiple fractions, so that can be a bit of a problem. So let's start with 2/3 here, oops, and 3/5. And when we cross multiply, we always multiply towards the top. Has to always be towards the top, and we're crossing, which is why it's called cross multiplying. So 2 times 5 is 10. Oh, sorry, that didn't turn out very well. Let's fix that up there. 10. And then we cross multiply the other way. 3 times 3 is 9. So that means then 2/3 is the larger of the two fractions. We're going to go back to our Explore section and try some comparing of two fractions using a number of strategies. So let's start with 1/2 and 1/3. Oops, sorry. 1/2 and 1/3. And let's use our number strips strategy. So we need to create two number strips that are the same length. And now we're going to have to try to divide them as equally as possible. So 1/2 is not bad. Cut your shape right in half. 1/3 is going to be a little bit trickier. We'll try our best here. Try to make them as equal size pieces as possible. Not quite equal. This is where your grid paper can be very helpful. Now we shade in one on this side and one on this side, and we can very clearly see that 1/2 is the larger of the two fractions. Let's take a look at the next two here. 6/12 and 3/4. Now I'm going to try fraction circles here. Actually, no, I'm not. I'm going to change my mind because 12ths is going to be very hard to draw. So that's something to consider when you're looking at what fractions you would like to, or what strategy you would like to use. Instead, I think I'm going to try cross multiplication. So in cross multiplication, again, remember we're going up and we're multiplying up on both sides. So 6 times 4 is 24, and 3 times 12 is 36. And you may use your calculator throughout this unit. There's quite a bit of math that needs to be done, so calculators are perfectly fine. And I can see that, 36 is larger than 24, so that makes 3/4 the larger of those two fractions. All right, and now let's use a different strategy. For 5/6 and 9/24. We could use a number line That would not be great just because you're having to divide your line into 24 little sections, so that's not wonderful. I'm going to use equivalent fractions for that one, I think. So 5/6 and 19/24. So I'm looking for a common multiple between 6 and 24. And in fact, I know that if I multiply 6 times 4, it is 24. And then we can very easily compare, because again, I've made them very much the same with the bottom number being the same. And with equivalent fractions from our last lesson, we know what we do to the bottom, we have to do to the top. So I'm going to multiply by 4 here as well. And 5 times 4 is 20. And now I can very directly compare these two. And I can see that, in fact, this one is larger because 20 is more than 19. So 5/6 is the larger fraction. Next, we'll do 3/8 and 2/8. Generally speaking, when the denominator is the same, we can just compare the two top numbers. And we can see automatically that 3 is larger than 2. And sometimes we don't actually really have to do much work as far as that's concerned. However, we're going to try this one with drawing circles because 8s aren't bad for drawing circles. So that's why I'm going to choose that strategy. I'm going to draw 2 circles that are approximately the same size, or as close to possible as I can get. I'm going to take it, divide it into fourths, and for 8s I'm going to take each half and divide it into half again. So now I have 8 parts. Same thing on this side. I want to make them as equal as possible, and I'm going to shade in 3 on this one and 2 on this one, and I can see as well that 3/8 is the larger fraction. All right, we're going to try question 3 in your practice together. You can use whichever strategy you prefer. Notice though this is 3 fractions, so you have to be careful and use a strategy that will actually allow you to only use 3 fractions to look at. So go ahead and try that now, 3 fractions. You choose whichever strategy you prefer. All right, so we are comparing 1/2, 7/10, and 4/5. It says to use number strips. What the heck? I'm going to use number strips. Okay, so I have to draw 3 of them. They have to be equal in size, or at least length. And now I need to divide them. So one needs to be divided only in half. That one's pretty easy. The other 2 need to be divided into 10 and 5. Ooh, that's going to be tricky. Let's start with 5 on the bottom there. Okay, those parts are fairly equal. Now 10 is going to be kind of right in the middle of that. Not loving that. They're not 100% equal. Perhaps maybe even using your ruler and making each strip 10 centimeters would be a good idea. And then each centimeter could be your spot that you mark for the 10, and then for 5 it would be every 2 centimeters, and then half would be, well, half of 10, which is 5, which would work quite nicely. All right, so I'm going to color in 1/2. Okay, here I'm going to color in 7/10, and I'm just going to color in the middle bit here so that you know which part's colored, but I'm not going to worry about it too much. And then here I'm going to color in 4/5. And then in this case, 4/5 would be largest, 7/10 would be second, and 1/2 would be smallest. I could use equivalent fractions to help me check this too, because I could say, okay, I'm going to make all of these out of tenths, because look, if I multiply by 5 here, I can make it out of tenths. If I multiply by 2 here, I can make it out of 10. So, all right, if I look at this, 1/2, if I'm multiplying by 5 on both sides, that's going to be 5/10. 7/10 stays as it is. 4/5, I'm multiplying by 2 on both sides. 4 times 2 is 8. 5 times 2 is 10. So really we're looking at 8/10, 7/10, and 5/10, which works quite nicely. So I can use equivalent fractions in this case to compare as well, because there are there's a possible denominator that can be the same for all three of them. This concept is quite tricky, so it might take us some time. All right, you're moving on to the concept practice. It is page 172, numbers 2, 5, and 7. Note, again, use whatever strategy you want. You don't have to use what it asks you to use in the question. If you'd like to, you certainly can, but you can use whichever strategies you prefer. Cross-multiplying, equivalent fractions, number lines, paper strips, circles, whichever strategy you find works best for you is just fine. Actually, I'm going to add question 12 as well. So make that 2, 5, 7, and 12 for you to take a look at. All right, and again, here are the text pages in case you forgot your textbook. Taking a look here, 1 to 5, or 1 to 4. And here you have 5 to 8. And lastly, 9, 10, 11, and 12.